So in order to simplify, which we have to be able to do really well because then multiplication and division is really easy. In order to simplify, our first step is to GCF for difference of squares, the numerators and the denominator. So this one here, I can't do anything to it. I have c minus 4. But if I want to compare it to the denominator, it would be in our best interest to write them both in the same order. So this one I have c minus 4. This one I should rewrite it. The sign that's with it goes with it. So negative c plus 4. Now remember, if they have plus or minus signs between them, they are sewn together with titanium. And how I show that is by putting brackets around it. Right? Okay. I can't do anything to the numerator or denominator with a GCF or difference of squares currently. So I'm going to state my non-permissible values first. So I'm going to go non-permissible values or restrictions. Either word works, but NPVs does not. Can't show our form on diplomas. So we get negative c plus 4 can't equal 0. And then you can either subtract the 4 and divide by negative 1, or we can just add the c over. So c can't equal 4. So I have my restrictions, so that's good. And then if I can cancel stuff off, I can cancel. But currently I cannot cancel. The top is positive c minus 4. The bottom is negative c plus 4. So those are the exact same terms, but wrong signs, correct? What changes signs? Multiplying by what? Negative 1. So what would change signs the opposite way? Would dividing by negative 1 also do that? If you divide by negative 1, it takes and changes the signs too, correct? So what I could do is in the numerator, if I wanted to, or the denominator, I can take a negative 1 out. I'm going to do it to the numerator just to prove a point because a lot of people want to do it to the denominator. So if I take a negative 1 out of my numerator, c divided by negative 1 is negative c. Negative 4 divided by negative 1 is positive 4. Now what can we say about those two terms? They're binomials. So a binomial can only cancel a binomial off if they are replica twins. Are they replica twins? Do they match in every way? Yeah. So before I cancel off, I slap my hand and say, did I state restrictions? I did. So can I cancel now? Yes. So I always have to state restrictions first. So it equals negative 1. If you're someone who's missed tests, you need to come talk to me. We need to set them up. All right. B. 2p cubed minus 4p squared over 16 minus 8p. So the top, the numerator, what can I take out of it? What can I take out as a GCF? 2 and a p squared. So I go 2p cubed, take out a 2p squared as division. So I'm left with just a p. Minus 4p squared divided by 2p squared, I'm left with a 2. Okay? We're going to remind ourselves that the p minus 2 is sewn together by titanium. So that's a binomial. This 2 and p squared, are they sewn together? Is there any plus or minus sign between them? The 2 and the p squared? No. So they're monomials. I can put them in their own brackets. Now some people are like, I'd rather not. You do you. But I learned that the people who actually put them in separate brackets get the question right more often than the people who do not. So I would promote that every time you have a monomial, you write those in brackets so that you realize the 2p squared does not need to match on the bottom. If I have a 2 and a 4, I can cancel something out. Correct? It doesn't have to be with a p squared. And the people who don't put it in brackets think that it has to be with the p squared. And that is not the case because the 2 and the p squared are monomials. So they are not attached. There's no plus or minus sign. Okay? So I know it's an aggressive amount of brackets, but I promise you it gets people canceling better. Okay? But you do you. You choose whatever you want. All right. We have 16 minus 8p. What can I take out of both? An 8. Now what I'm going to show you first is I'm actually going to rewrite that. I'm going to go negative 8. So I'm going to go 2p cubed minus 4p squared equals No, do not freeze on me. Stop it. It's gonna freeze and yeah. Great. Okay, so okay, let's try this again. So we have a 2p squared, and we're left with p minus 2. 2p squared are monomials. And then the bottom, I won't rearrange it because I didn't like it, so I'm not going to test the computer again. If I take an 8 out, I'm left with 2 minus p. And this 8's a monomial. Now, what's the problem here? I have a positive p and a minus 2, and I have a positive 2 and a minus p. Does it matter that they're out of order? It doesn't matter that they're out of order. It matters that their signs are different, because your sign has to come with it. Okay? So it doesn't matter that I have 2 minus p. That is not my issue. The 2 coming first is not my issue. The issue is up here I have a negative 2, here I have a positive 2, here I have a positive p, here I have a negative p. So instead of taking out an 8, what should I have taken out of? Negative 8. If I take a negative 8 out, this becomes negative 2 plus p, and guess what? They're actually the same now. Because it's the sign in front that matters. Positive p, negative 2, positive p. You see that? So I know they can cancel, so I'm going to put a line through them. No, I'm not. I'm going to slap my hand. I'm going to say what? Restrictions. And they only come from the denominator, because your denominator can't equal 0. I can have 0 in the numerator, just not in the denominator. So I have negative 8 can't equal 0. True statement. Do I care about it?
No.
No. So do I even need to write that? No. Then I have negative 2 plus p can't equal 0. I'm going to add my 2 over. And p can't equal 2. Everyone should be writing this down. These cancel off now. And the 2 and the negative 8 I can take out at 2. So this would be a 1, and this would be a negative 4. So my answer is p squared over negative 4. P can't equal 2. Look at the next one. What can I take out of the next one in the numerator? Can I take anything out? It's a difference of squares, exactly. So it is 25 minus x squared. So if I do the difference of squares in the order that it is, I'm going to get a 5 minus x and a 5 plus x. We should look around to the rest of our rational and see, is there anything else that might hint if that's a good idea or not? Let's look at the denominator. The denominator is x minus 5, not 5 minus x, correct? So instead, what could I do to this numerator so that I can rearrange it? Take out a negative 1. So this is currently positive 25 negative x. I could rewrite it as negative x squared plus 25. But a difference of squares has a different sign in the middle, correct? So what would be better is to take a negative 1 out. So I get negative 1 x squared minus 25 over x minus 5, 2x plus 1.
Why are you switching places? It was 25 minus x squared, now you're saying x squared minus 25.
Because I want an x minus 5, not a 5 minus x. If I do the difference of squares, currently how this is sitting, Colton, I'm going to get 5 minus x, and then 5 plus x. And I need x minus 5, and this is positive 5 and a negative x. And this is a positive x and a negative 5. So I see that this is in the order x then number, so I want this in the order x then number. So I rearranged it first because I have to take the negative sign with the x and the 25. And then I was like, wait a second, I need the negative in the middle to make a difference of squares. So I have to take a negative 1 out. Does that make more sense? Okay. All right. So then I'm going to get -1, and now I can do the difference of squares of that and have the x come first and the 5 come last. So I'm going to get x plus 5, x minus 5, and then some people see things that can cancel and they get excited because they're like, okay, I'm not done. Things are going to cancel. This is good. Like, it gives you a little bit of positive reinforcement that you're kind of doing something right, maybe. Because rationals don't always give you positive reinforcement. Okay? The catch here, though, is that we can't cancel until we do what? Restrictions. And we're going to get 2 restrictions because we have 2 different binomials in our denominator. Correct? So, however many brackets in the denominator have a variable in them is how many non-permissible values you're going to get. So this first bracket has an x in it, the second bracket has an x in it. I'm going to get 2. Okay? So, x minus 5 can't equal 0. Add my 5 over. X can't equal 5. And then I have 2x plus 1. The moment that your x has a number in front of it, people, we are going to get a fraction. Yes? Because we're going to subtract something over and then divide something under. Now, sometimes it's like 8 divided by 4 and you get a 2. Right? Sometimes it's nice, but most of the time it's not. So this one, we'll subtract the 1 first. We get 2x can't equal -1, and then we divide by 2. X can't equal -1/2. I'm going to forewarn you. Rationals often is the unit that people struggle the most with. So it's the one you have to give the most effort to. Okay? A lot of 20-1s, if you came from 20-1, no matter what your mark is, rationals was harder and you did the whole unit of it. So often people, if they put in the effort, can do really well in this. 20-2, some of you have seen this, some of you have not, depending on who you've had, and you've seen part way through. So you're going to have to put in the effort to do well in this. Okay? Either way, the effort in this unit has to be 3 times the effort in your previous 2 units, if you want to do well on it. Okay? All right. Because practice makes you do better at these. So I stated my non-permissible values. Now I'm allowed to cancel off twins that match. So binomials with binomials, monomials with monomials, right? A monomial can never cancel off a binomial. Side note, to remind you of that, because we've had a test and a little bit of other stuff in. If I have a 3y in the numerator and a 3y minus 1 in the denominator, I get a ton of people canceling off those 3y's. Bad news bears. You have to remember that binomials can cancel off binomials and monomials from monomials, so you stop illegal cancellations. And you're like, I would never do that. 70% of you will do this, at least. It makes me sad, too, because we all agree to not do it, and then you're like, oh, more canceling. No. This 3 and this y are in their own brackets. They're a monomial. They're attached to nothing. They're actually 2 monomials, correct? And then this 3y minus 1 is a binomial. So can I cross off the 3y with the 3y minus 1? No. If I had a 9 in front of here, could I go canceling some stuff off? The 9 and the 3? Yep. If I had a y squared? Sure. If I had a 3y minus 1 exactly on the top? Yes. Oh, no desk for you, latecomer. All right. So, let's cancel. Goodbye, sayonara. And we're left with -1 x plus 5 over 2x plus 1. And then I always follow behind with x can't equal 5 and -1/2. And there will always be people paying attention, please. Remember, I know common error 101. I've watched common errors happen constantly. There will be people that will tell me that the only non-permissible value is -1/2. Why would they do that? Because the 5 is gone, and they state restrictions after they cancel. Do you think the answer to stating restrictions after you cancel will be on your test? Yes. It's wrong, and it'll be there. Because remember, it's 1 right answer, 3 common errors. That's how every test is ran. It's not 1 right answer and then puppy, kitty, and muffin or something. That would be the best thing ever. That is not the way it is. So, there will be this answer written like this, then there will be this answer without the 5. So if you don't know that you need to state restrictions before you cancel, you'll be wrong. Now let's understand why, guys, because remember I told you if you understand why you do something, you'll do it. If you just memorize, you might forget it. Why do we have to state restrictions before we cancel? Because in every step, we cannot fail. We cannot make a bad math move, okay? So let's look up here. If I didn't have, everyone's paying attention to me, right? Because we're understanding why. If I didn't have x can't equal 5, it would fail in the very first step, wouldn't it? Because I could fill in 5 minus 5 and I'd get a 0 here and it would fail. So I have to have x can't equal 5, because if not, then I could just plug a 5 in this very first step, 5 minus 5 right here, and that would be 0, I'd fail. It would fail here, it would fail here. The only place it wouldn't fail is finally in the last step, but it failed 3 times before it got there. Okay? So you have to state your restrictions for any time an x would fail. And that x equals 5 would fail in the first 3 steps, so it needs to be stated. Okay? So we have to understand why, not just memorize that I have to state before I cancel. Okay? All right. B. We have to be able to do this. Multiplication, no joke, is just 2 rationals that I have to simplify instead of 1. It's like 2 of these questions combined. That's what it is. So if I can't do this, then I can't do 2 of the questions combined. Right? Okay, that's why we're spending so much time on this. For D, can I take out a GCF or a difference of squares? GCF, what could I take out? I can take out a 2, and then I'm left with p squared minus 128 divided by 2 is 64, which is a difference of squares. We'll hit that up in the next step. Yeah, next spotting. And then the bottom, I can take out a what? I can take out a 2, and then I'm left with 8 minus p. We'll discuss that in a little bit. I see those 2's can cancel off, but I'm not going to cancel anything until I've stated my non-divisible value. Okay? The top, Colton said, is the difference of squares, which is true. So I'm going to get 2 p minus 8, p plus 8. And then to make it a little more noticeable, I'm going to rearrange these. So I'm going to take this, and I'm going to put the p first. And the only reason why I'm going to put the p first in the denominator is the p's are first in the numerator, right? So it's a lot easier to compare them when they're both in the same order. So I have a negative p, so I have to write that first. And then I have a plus 8. Do I have any twins? I have binomials. Do I have any twins currently? Do I have any people that are very close to twins, like they're wearing different clothing, but they look pretty much the same? Yeah. Like this one here is p minus, a positive p and a minus 8. This is a negative p and a plus 8. So those are twins in the opposite clothes. How can I fix their clothing? Take out a what? Negative 1. So instead of taking out a 2, what should I have taken out? Negative 2. So if I take out a negative 2, this becomes a positive p, and that becomes a negative 8. Now do they match? Now do I have some twins in the same clothes? Yes. So I'm going to cancel them off right now. I'm going to do my NPVs first, my restrictions first. So I'm going to go to my restrictions. And I'm going to say negative 2 can't equal 0. Well, that's not going to get me a restriction. And if we look, these are monomials. Okay, get my blue marker out. So it's a monomial and a monomial. Monomials, like without a variable, this bracket has no variable, correct? If the bracket has no variable, it produces no restrictions, because it is the number negative 2. And our restrictions come from when that could be 0, which it can't be. And then we have p minus 8 can't equal 0. And I add my 8 over. P can't equal 8. So that's my only restriction. And I'm going to state at the end. I've stated my restrictions, so now I can cancel. Monomials for monomials, binomials for binomials, right? So, p minus 8, p minus 8. Now some people will say, but Mrs. Lepp, you have a plus in front of that p, and the other one doesn't. Did I need to write that plus? Or did I just take that minus sign and make it a plus so you could visualize that it became a plus? Yes, they are the same thing. And then the 2 and the negative 2 can cancel, and I'm left with a negative 1 in the denominator. So technically I'm left with p plus 8 over negative 1, which is not wrong. They will just never write it like that. they'll take that -1 and they'll bring it to the front. Only a -1 can be brought to the front. And if you don't believe me, what you could do is you could multiply this by -1 to make that a +1. And what you do at the bottom, you have to do to the top. So then this would become a +1. And then I'd be left with -1 p plus 8. So you see how that can come up? By just multiplying by -1. And you do the bottom, you have to do the top, you can't just randomly add things by multiplication. And then p can't equal 8. All right, so for the next 15 minutes, I'm going to have you actually work on questions out of the workbook. And then we're going to move on to multiplying. Because you need to practice these. Like I said, if you can't do this, you can't multiply or divide. If you can do this, multiplying and dividing is super easy. Literally just this. So, good or bad, you can do this, multiplying and dividing is super easy. You can't do this, you can't multiply or divide. So it's very important you can do this. So, in your workbooks, you're going to be doing page 435, numbers 3 and 4. Number 3, you already did NPV's books. 3 and 4. Multiplying and dividing. So, we are going to do the exact same steps as simplifying. We just now have 2 of them. So what's better than 1 rational?
None.
2.
None.
Right? None could be an answer. But 2 is the correct answer. All right. So let's look here. Do you see how this is 1 rational? This is 2 rationals, correct? We do the exact same steps as simplifying. So we're going to go to every numerator, top, and every denominator, bottom, and we're going to see if we can take out GCFs or difference of squares. But the very first thing we always check is for a greatest common factor, and then after that, difference of squares. Okay? So let's look here. So I'm going to put an equal sign, because this expression is going to be equal to the next one. Same thing with simplifying. So for all of these, multiplying, dividing, adding, subtracting, simplifying, we're simplifying all of them. So every step is going to have an equal sign running down the left-hand side, because every single rational expression is equal to the next one. Okay, ready? I'm going to look at the top left. I have a binomial. It's sewn together, correct? It is an x plus 1. Can I take anything out of that? No. So I'm going to put it in brackets because it is sewn together. All over left, x plus 3. What are we going to do with that? Nothing. We're going to put it in brackets because it's a binomial. It's sewn together. Wow, I did 1 rational already. That was easy. Need a button. Then, really sold that. That was easy. I just stopped in monotone. Okay. Next one, we have 2x plus 6. Can I do anything to that? Take out a 2. And then I'm left with x plus 3, which is a binomial. So it's sewn together. And then, I don't know if I still have a blue pen, so I'm going to go get it. And then this is a monomial, so I'm going to put it in a different color. So monomials can cancel monomials, binomials can cancel binomials. We're going to look at the bottom right, so the denominator on the right-hand side. What can I take out of it? An x. And then this is where people mess up. What's left behind? X plus 1. A lot of people will say x. Remember, when you distribute it back, you have to get what you had. So if you just put x, you just have an x squared, correct? So when I distribute that back, I get x squared plus x, and I put this in brackets. At the very least, you should have a pen or a pencil in your hand and be copying this down on the notes package that I printed for you. Yes. Good talk. All right. So, before we go to cancel anything off, what do we have to do? Restrictions, same steps. We're doing all the same steps, correct? I haven't changed anything. So now I'm going to actually have 3 of them, because I have x plus 3, x, and x plus 1 are all in the denominators. Okay? So my restrictions are x plus 3 can't equal 0, x can't equal 0, and x plus 1 can't equal 0. Right? Then I need to solve them out. So I took all three of them. X plus 3, x plus 1. I'm going to subtract 3 from this one. And I'm going to get x can't equal negative 3. X can't equal 0 is done. And this one I'm going to subtract 1. X can't equal negative 1. Do we agree?
Yes.
Okay, get ready for this. This is going to be difficult. I'm being facetious. Okay, ready? The crowd goes, wow. Because when you multiply fractions, numerators get multiplied by numerators, and denominators get multiplied by denominators. So I can just bad boy line through, right? Because the numerator is going to join the numerators, and the denominator is going to join the denominators. Now I have one simplification statement, like I did in the previous lesson. So anything in the top that matches anything in the bottom, we can cancel. So is this any more crazy than the previous lesson? If you can't do the previous lesson, you understand how you can't do this one, though, right? They go together. So, x plus 3, twins with this x plus 3. X plus 1, twins with this x plus 1. And then I have 2 by itself. Is there any number? Is there any number? Any number on the bottom that matches the 2? No, there's no number down there. Is there any varabula that matches the varabula on the top? Am I putting the wrong emphasis on the wrong syllable? Okay, so we get 2 over x. And then we say x can't equal 0, comma, negative 3, comma, negative 1. Boom shakalaka. We done. The answer is...
Answer?
Answer.
Are you dyslexic?
Nope, that's not what dyslexia is. All right. B. B is 12x squared over 3x squared plus 6x. And then 4x cubed over 8x squared. Or 4x cubed plus 8x squared over 5. So, it's multiplication. Same as before, right? We're going to run an equal sign down the left-hand side. And we're going to simplify. So let's look at the left-hand side numerator. We have 12x cubed. That is a what? Starts with an M, rhymes with monomial. Monomial. Geniuses. Thank you. Thank you. Don't let anyone tell you different. Okay, it is a monomial. So what did I tell you to do that you guys are all rebelling against because I'm watching you? 12x cubed can go in brackets. But the 12 can go in brackets separate from the x cubed because a monomial means that all those things are just being multiplied, correct? So we have 12x squared, and by squared I mean cubed, 12x cubed, and the 12 and the x cubed are in their own brackets. And they're in blue because they're monomials. Okay? In the bottom I have a binomial. The 3x squared is being attached by titanium to the 6x. Yes? So I can't put those in separate brackets. But I asked myself, can I take out a greatest common factor, a GCF? What can you take out? 3x. And then 3x squared divided by 3x is x plus 6x divided by 3x is 2. That's a binomial, so it's in blue. I can recheck it. 3x times x is x squared. 3x times 2 is plus 6. Like, you can double check your GCF, right? It should come back to what you have. Now, this 3 and this x are a monomial. There's no plus or minus sign, so I'm going to put them in their own brackets in blue. Boom, boom. Multiplication sign. Right-hand side. What can I do to the numerator on the right-hand side? 4x cubed plus 8x squared. Take out a 4x squared. And then 4x cubed, take out a 4x squared and left with x. Plus 8x squared, take out a 4x squared and left with 2. And then that 4x squared is a monomial. We agree? All of our greatest common factors are monomials, so they can go in their own brackets. And then we have a 5 in the bottom, which is a monomial, so it can go in its own bracket. So what do I always have to do after I've done the greatest common factor and difference of squares? Restrictions. So let's discuss them. So our restrictions are 3 can't equal 0. Is that actually a restriction? Does that have a variable? No, so she's gone. Then I have x can't equal 0. Box it. Then I have x plus 2 can't equal 0. Subtract 2 from both sides. And x can't equal negative 2. And then I have 5 can't equal 0. Great statement, but is it a non-permissible value or a restriction? No, it doesn't have a variable. So my two restrictions are 0 and negative 2. And if I put them back in, I put a 0 in here, that whole side would cancel and become 0. So that is a restriction. Okay, now here's where the crazy part happens. This is the hard part. Just stretched before that, obviously. That's the most difficult part. So anything in the numerator can cancel anything in the denominator because the numerators multiply, the denominators multiply when you multiply fractions, right? Numerator times numerator, denominator times denominator, so I can just line straight across. So what can cancel? The x plus 2's can cancel. What else? The 12 and the 3? Some people say 12 and 4. 12 and 4 are both in the numerator, so can they cancel? No. So the 12 and the 3 can cancel. If you don't spot that, guys, if you don't spot something and you're like, I don't know if I can cancel more, put everything together and then cancel in the next step. Yeah?
And the x's beside the 12 and 3 also cancel or no? It would turn into an x squared.
Yeah, it would turn into an x squared because you only take one out. But it can come from one or the other, right? So I can take an x out of the x cubed or an x out of the x squared, but I can't take it out of both of them. So it's one or the other.
Take it out of the x cubed, it works.
Yeah. If it's confusing, guys, and you have just monomials left, write them over. So let's do it this way. We can cancel those off and we'll get an x squared and we get an x4. Or watch this. 12 times 4 is 48. X cubed times x squared is x to the what? Yeah. Over 3 times 5 is 15 and an x. Okay? So if it's overwhelming to cancel them in this step, which sometimes it is, put them together and then cancel them in the next one. It's not a big deal, okay? Whatever works better for you, yeah?
Yeah, where's 48?
12 times 4. 12 times 4. Okay, what can I take out of 48? What can I take out of 48 and 15?
3.
A 3. Now do this. Pick up your calculator. So I can either say that I can take a 3 out of both of these, and then this is going to become 16 over 5, or we can use the reduced fraction button. It only works if you have monomials, though, right? And then what can I take out of the x's? This x and one of those. So I'm left with x to the 4, and it's sitting in the numerator, so it stays there. Now, what we could have done up here, I'm just showing you, instead of putting them together, what we could have done is we could have done 12 divided by 3, so 3 becomes a 1, 12 becomes a 4, and then this x can cancel off one of those, so I'm left with a 2, and then I would still have to put them together, though. 4 times 4 is 16, x squared times x squared is x4, and then this would become just 5, 1, 1, 1, 1, 5, right? So which one is better? The one that gets you the right answer. The one that you can physically get the right answer with is what is better for you. Some people can cancel right away in that step and get the right answer. Some people canceling in that step causes sheer chaos and never gets the right answer. So if that is the problem, if canceling off in that step is sheer chaos, just take all your monomials, put them together as one thing, take all your monomials in the denominator, put them together as one thing, and then cancel, like we did in this step. Okay? Whichever gets you the right answer. And then we're going to follow behind with x can equal 0 or negative 2. So your homework tonight is that simplifying homework. You're going to finish multiplying and dividing tomorrow.